In this installment of Toyota's Engines 101 series, we're taking a closer look at one of the most critical parts of an engine, its valvetrain. This component has a massive impact on the overall performance and character of an engine since, in a nutshell, it's how the engine breathes. So let's first explain what exactly constitutes a valvetrain before getting into some more advanced aspects like how valve timing works and how it can be used to enhance not just performance, but also efficiency. Without a valve system, the entire concept of an internal combustion engine simply wouldn't work. An engine's cylinders need intake valves that open to pull air in and exhaust valves that open to push the exhaust gases out, effectively inhaling and exhaling with each cycle, creating the power that ultimately turns the wheels. These valves are opened and closed by a component called a camshaft. By aligning the camshaft's lopsided lobes with the valves, it can push against them as the camshaft turns, opening each one with every rotation. And since this camshaft is connected to the crankshaft, the valves stay in time with the rest of the engine, regardless of RPM. Valvetrain design can vary in a few common ways: how many valves there are, how many camshafts operate them, and where the components are located. First, most engines nowadays use 2 valves on the intake side and 2 valves for the exhaust, making for 4 per cylinder. Next, some vehicles use a single camshaft to manage both intake and exhaust valves, while others use a dual camshaft layout with 1 for each side. Finally, while most modern vehicles have the camshafts mounted above the valves to simply control them directly, some also place the camshaft below the valves, in the block, and instead use a system of push rods and rocker arms to actuate the overhead valves. So, have you ever seen a vehicle with a 16-valve or DOHC badge and wondered what that meant? Well, 16-valve on a 4-cylinder engine indicates that each cylinder has 4 valves. And DOHC stands for Dual Overhead Cam, which further describes that vehicle's valvetrain layout: 2 camshafts positioned above the valves. So that's how a valvetrain works, but it's not the whole story. Timing those valves correctly is a delicate tightrope walk between smoothness, efficiency, and power. We're talking fractions of a millisecond making a huge difference. That's why hitting an ideal balance at 1500 RPM might require a different timing than at 5500 RPM. That's where variable valve timing comes in. Nearly all auto manufacturers have a variation of this technology, and Toyota's is known as VVT-i, or Variable Valve Timing with Intelligence. The details of this feature can vary by model, but the goal is the same. The basic design centers around the cam gear that pairs the camshaft to the crankshaft. By implementing an internal shifting mechanism within this gear, the rotation of the camshaft can be pushed slightly forward or backward, which then advances or delays the opening of the valves accordingly. This way, valve timing can be adjusted without impacting the rest of the engine cycle, which in turn enables the ability to maintain an ideal balance across multiple RPM ranges. Now, this brings us to our next point. Instead of targeting a perfect balance, what if valve timing could be adjusted to maximize efficiency? Well, this is exactly the thinking behind Toyota's modern take on the Atkinson Cycle Engine design. This design takes a different approach to combustion compared with the usual Otto cycle engine of a typical vehicle. Without taking a deep dive into automotive history, the general idea is this. With the Atkinson design, the intake valves are kept open into the compression stroke. This effectively shortens that stroke while still maintaining an expansion ratio based on the full cylinder. This in turn results in a lower compression ratio, reducing the energy needed to compress the air-fuel mixture. The benefit here is that virtually all of the fuel is burned while still inside the combustion chamber, helping to reduce emissions and maximize efficiency. The flip side, however, is it means that the pistons aren't firing with the maximum possible amount of pressure and power. This trade-off in power is why Toyota is selective about when it gets used. For instance, it makes sense to use it when full power isn't needed, like highway cruising. This is the idea behind Toyota's wide-range VVT-i system, where the engine can flip between auto and Atkinson modes as needed. It also makes sense to use Atkinson Cycle full-time if it's being supported by an additional power source, like an electric motor. This is the thinking behind a typical Toyota hybrid powertrain. So that's a brief look at the Valvetrain design of an internal combustion engine. Not just what it is and how it works, but also how its timing can be adjusted for either an optimum balance of power and efficiency, or even to crank the efficiency to the max. To learn more about the technology inside Toyota vehicles, or even just automotive engineering in general, be sure to check out the other videos in this series, which can be found on Toyota's YouTube channel.